This video is for section 5.1, measuring the size of an angle using radians and degrees. If I was in class for this first section of the trigonometry unit, I would ask you to read some information in the book, and then I'd give a lecture, ask you to take notes, and do a lot of guided practice problems. So this video is going to replace that. We're starting a new chapter about trigonometry. The word trigonometry means the measurement of triangles. Originally, trigonometry was used to explain relationships between side lengths and angle measures in triangles. But it's now used to model many more things, such as phenomena involving rotation or vibration, sound waves and light rays, the orbit of planets, pendulums, the orbits of subatomic particles, the motion of springs, the cyclical nature of seasons and the climate, and some biological processes. In pre-calculus class, we'll begin using trigonometry from the perspective of angles. That will connect it to your understanding of trigonometry from geometry class. But later we will move to using trigonometry as functions that model real-world phenomena. One trigonometric function you've heard of from geometry class is called sine. You can evaluate the sine of an angle measure. For example, the sine of a 45-degree angle is the number 0.7071 if you round it to 4 decimal places. You can also find the cosine or the tangent of an angle measure. So you can see that trigonometric functions, sine, cosine, and tangent, are functions done to an angle measure to create an output number. Thus, it makes sense to begin our unit about trigonometry by discussing angles. Here are a whole bunch of vocabulary words in this section of the book. An angle. An angle is formed by rotating a ray about its endpoint. Here's an example angle. Here is a ray pointing to the right. If you rotate that ray in this direction, and then redraw the ray, that object that is formed is called an angle. The initial side of an angle is the starting position of the ray. In the example that I drew, it was this first horizontal ray. The terminal side of an angle is the position of the ray after rotation. In the drawing that I made, this ray pointing up at an angle is the terminal side of the angle. The vertex of an angle is the end point of the ray. It's this point right here, the point where the initial side of the angle intersects the terminal side of the angle. Standard position of an angle is when the angle is drawn on the xy plane such that its vertex is at the origin and its initial side is along the x-axis. A positive angle is an angle formed by counterclockwise rotation of the ray. If you think of an old-fashioned clock, the kind that has the hands that go around in a circle, counterclockwise is this direction of rotation. A negative angle is an angle formed by clockwise rotation of a ray. Clockwise is when rotation is occurring in this direction going around a circle. In pre-calculus class, it is common to label angles with capital English letters, like A, B, C, D, E, however many letters we need, or with lowercase Greek letters, such as alpha, beta, or theta. And if you need more Greek letters because you have more than 3 angles, you could use other Greek letters. Next, please take some notes below. Let's draw an illustration of a positive angle in standard position. This way we're exploring what a positive angle is and also emphasizing what standard position is. The first thing you need to do is draw an XY axis. So here's Y, here's X. Now on that, let's make a positive angle that's in standard position. First, start at the origin and draw a ray that traces the x-axis. Then rotate in a counterclockwise direction as far as you want to and then draw the terminal side of the angle. I chose to draw an obtuse angle. The measure of this angle is more than 90 degrees. But this is a positive angle. It has a positive angle measurement. Visually, it looks to be about positive 135 degrees. This is in standard position because the vertex is at the origin and the first side goes right along the x-axis. Now over here, let's draw a negative angle that's in standard position. First, make your y-axis and x-axis. And then on that, we'll draw our angle. To be in standard position, you have to start at the origin and have one side of the angle trace the x-axis. Then let's draw the terminal side of the angle. To be a negative angle, we have to have clockwise rotation. So we want to rotate around this direction, as far as you want to, but then draw the terminal ray. This angle from here, rotating to here, is our negative angle in standard position. This looks to be approximately negative 70 degrees. Our next vocabulary word is coterminal angles. These are two angles that have the same initial and terminal sides. Let's take some notes on this by drawing some examples so we can make sense of what this vocab word is describing. First, let's draw our y-axis and x-axis. And on there is where we'll draw our angles. Let's draw any angle to begin with. So start at the origin, trace to the right, and then come up however far you want and draw the other side. So there's an acute angle. It looks to be about 45 degrees. Now I'm going to change colors, and we're going to draw another angle on the same XY plane that's coterminal with the one that I drew in blue ink. The first side has to go along the x-axis. Then for this angle, I'm going to rotate in the negative direction, going past negative 90, past negative 180, past negative 270, and all the way to where that blue line is, and then draw the green ray. The first one was done in blue ink, but I've since traced over it in green, so you can't really see the blue anymore. It was this angle inside here, which was about 45 degrees. And the other angle went in the negative direction all the way around to that side right there. The measurement of that angle is about negative 315 degrees. A 45 degree angle and a negative 315 degree angle are coterminal. They start along the same ray and they end along the same ray. Let's do another example. So here's the y-axis and the x-axis. And draw any angle you want to be the first angle. So start at the origin and draw straight out to the right, and then rotate counterclockwise if you want a positive angle, or rotate clockwise if you want a negative angle, and make it acute or obtuse or right angle or whatever you want. I'm going to draw straight down the y-axis like this. This is my angle, negative 90 degrees. Now I want to draw a second angle on that same XY plane that's coterminal. The first side of the angle is going to go right along the x-axis. One way to make a coterminal angle would be to rotate counterclockwise, 270 degrees, and then draw the line going down. But that's not the only way to make a coterminal angle. We could rotate in the negative direction again, but just go a lot farther than negative 90 degrees. Watch this. Negative 90, negative 180, negative 270, negative 360, keep going, all the way to there again. And then here's the ray going downwards. That second angle that I was doing in brown ink has a measurement of negative 450 degrees. I did a full circle, which was negative 360, plus an additional negative 90. A negative 90 degree angle and a negative 450 degree angle are coterminal angles because they start with the same initial side and they have the same terminal side. When drawing those examples, we refer to the measures of the angle so that mathematically we could see what it would mean for angles to be coterminal. The measure of an angle is the amount of rotation from the initial to terminal side. In geometry class, you're used to measuring angles using a unit called degrees. 1 degree is equal to 1/360th of a full rotation, or another way to say that is of a full circle. There's another way to measure angles, and that's with a unit called radians. 1 radian is equal to 1 radius of rotation. Well, what does that mean, a radius of rotation? This is the amount of rotation that creates an arc length equal to the length of the ray. The length of the ray is the same thing that you would call radius in your geometry class. Please take some notes below to make sense of what a 1 degree angle is and what a 1 radian angle is. So first thing, draw your y-axis and x-axis. A 1 degree angle is an angle that is 1/360th of a full circle. So the next thing I'm going to do is on that axis, I'm going to sketch as accurately as I can a circle. That's a little hard to do to get it all centered good. It's the best I can do. Now we're going to draw our 1 degree angle. Let me switch to red ink. Start at the origin and do the initial side going to the right. Then we're going to rotate counterclockwise because this is a positive 1 degree angle, but we only want to go 1/360th of the way around. You got to imagine separating this into 360 equal and tiny little pieces so that there's 360 of them going around there, and then just coming up that one mark. This angle is so small, so skinny, it's hard to draw it well. It's a lot easier to visualize an angle that's 90 degrees going upwards, or an angle that's 45 degrees if you drew straight out this way. But doing only a 1 degree angle is really skinny, a very small angle. Now let's contrast that with an angle that is 1 radian in measure. So here's the y-axis and the x-axis. And again, let's draw a circle on that to help us do rotation. So get your best circle on there that you're capable of. If you have a coin in your pocket, you might trace around that to get a perfect circle. Now I'm going to switch to red ink and draw a 1 radian angle. Start at the origin, trace the x-axis out to the edge of the circle like that. The length of that ray is a radius. Let's rotate in a counterclockwise direction around the blue circle for a length that's equal to that radius. I think we would need to rotate up to about this point right here and then draw in the terminal side. The idea is if this distance here is the radius, and then you rotate around the outside of the circle that same amount, that creates an angle that has a size of 1 radian. As a check for understanding question, please answer this. Assuming angles have equal length rays, which angle measure is larger, a 1 degree angle or a 1 radian angle? Well, looking at the two drawings up above, in which I made the rays about the same length in both pictures, we can easily see that the 1 radian angle is a much wider opening angle. So this one is larger. Next, I'm going to ask that you show your prerequisite knowledge that you have from geometry class by sketching some common angles on XY planes below. So there are 6 angles that I'd like you to sketch. For each of them, you first need to make an XY plane. So draw your y-axis, draw your x-axis. And then on there, draw the different angle measures that I've asked for. I'm going to ask that you pause the video at this point, make your 6 drawings, and then push play on the video to compare your sketches to my sketches. And here are my sketches. Now I didn't use a protractor, so these are simply visual guesses of what I think these angle measures look like. But I think I'm pretty close, so hopefully your angles look very similar to mine. Here's 180 degrees, opposite rays. And notice that I have positive rotation as shown by this arrow here, and I labeled 180 degrees. This one is 90 degrees. The first side goes out to the right, the second side goes up along the y-axis. Notice my little curved symbol here to indicate the positive direction for rotation. This acute angle is 45 degrees. This one here is 30 degrees. This is 60 degrees. And this last one is negative 270 degrees. Notice how I had to draw the symbol to show the direction of rotation so I could label negative 270. Otherwise, you wouldn't know. Maybe you would think that's a positive 90 because those two angles are coterminal. Next, please check out these examples of some angles that are measured in radians instead of in degrees. Again, for every one of these, we need to draw our angles on the x and y axis. So let's get those drawn on there first. If you're really terrible at drawing straight lines, then you might want to use grid paper or use a ruler. Likewise, if you're really terrible at rotating around a circle, you might want to actually draw circles. Again, you could trace a coin if you have like a quarter that you bring with you. For our first angle, let's make an angle that has a measurement of pi radians. The first side goes out to the right. The other side goes straight out to the left. From here to here is pi radians of rotation. Please observe how pi radians is like half of a full circle. Pi radians is the same thing as 180 degrees. Next, let's show an angle that is pi over 2 radians. So the first side just goes right out to the right along the x-axis. But then the other side goes right up along the y-axis. This angle is pi over 2 radians. Please observe that it's the same thing as a 90-degree angle. Pi over 2 radians is equal to 90 degrees. Next, let's draw pi over 4 radians. If pi radians is a 180-degree angle, or a half of a circle, then pi over 4 would be 1/4 of that. So it's like having a half circle that's been separated into 4 equal pieces, and then having only one of those 4 pieces. That is, drawing out in this direction. And there's the pi over 4 angle, an acute angle. The same thing as 45 degrees. Now let's do pi over 6. Well, here's the initial side going to the right. But where's the terminal side go? Remember that pi radians is half of a circle. So pi over 6 radians would be 1/6 of that. Think of splitting this into 6 equal-sized wedges. And then having only one of those wedges. That is, drawing out this direction. This angle in here is pi over 6 radians. Next, pi over 3 radians. That would have the initial side going like this, and then the other side going up here like this. There's pi over 3 radians. The same thing as a 60-degree angle. Well, how did I get that? I thought of this being a half circle. And pi radians is when you go all the way to the other side. So pi over 3 is 1/3 of that. So visually, I separated it into 3 equal-sized wedges. And that's how I knew that this side came up at this angle on the paper. Last, negative 3 pi over 4, also known as negative 3/4 pi. Let's draw that one. So the first side goes out to the right on top of the x-axis. This is a negative angle, so we need to rotate in this direction going around. But how far should we go around? Let's use our half circles to visualize this. From this point, rotating all the way to this point would be negative pi. But we don't have negative pi. We only have negative 3/4 of pi. So imagine this half circle being split into 4 equal wedges and having 3 out of the 4 wedges. So the terminal side comes down in this direction. Our angle goes from here to here. It's this obtuse angle. The last part of this lesson is a check for understanding. On the XY plane and circle below, sketch each of the 4 angles. And so we can tell which is which, label the point of intersection of the terminal side and the circle with the angle measure. I'll do the first one for you, and then I'm going to ask that you pause the video and try it, and then push play on the video to compare your drawings to mine. So first, let's do the 135-degree angle. Start at the origin, go right on top of the x-axis, not above the x-axis, just right on the x-axis. Then, this is a positive angle, so we're going to rotate this direction around the circle, 135 degrees. And when we get there, we're going to stop. And that's where we're going to draw the terminal side. So going all the way up to there is 90 degrees. If we had rotated all the way to here, that's 180. 135 is halfway between 90 and 180. That would be like right there. So the terminal side goes up to that dot. And then we're going to label this obtuse angle by writing 135 degrees at the location of this dot, instead of down in here where we normally do it. Because we have 4 angles to put on here, and it's just going to get too cluttered to try to label everything close to the center there. Please pause the video and draw those next 3 angles onto this same circle. And then when you're ready, please push play and check how you did. Okay, here are the answers. I'm going to do the 3 pi over 4 radians angle in red ink. So the first side goes right along the x-axis, just like that first angle we did. Now we've got to find 3 pi over 4 radians. When you rotate in the positive direction all the way to there, that's pi radians. But we don't have a full pi radians. We only have the fractional amount, 3 pi over 4. So that's 3/4 of the way to this spot. So if we rotate up to there, that's pi over 4. Rotate to there, that's like 2 pi over 4. Rotate to here, that's 3 pi over 4. So it's actually that same ray that we had already drawn. The 135-degree angle is the same thing as 3 pi over 4. Now let's do a negative 135-degree angle, and I'll do that in brown ink. So the first side goes right off to the right. This is a negative angle. We're going to rotate around this direction. Here we go. Negative 45 is kind of right there. Negative 90 is right down here. And then as you keep going, when you get halfway between that spot and that spot, that's where the negative 135 would be. So we'll draw the terminal ray and label that dot negative 135 degrees. So this obtuse angle in here is negative 135 degrees. Finally, let's show negative 2 pi radians. And I'll do that one in green ink. The beginning of the angle is right along the x-axis. You get that by now. Now we're going to rotate negative 2 pi radians. So in the negative direction, you're going around clockwise. Here we go. Ooh, right to there. That's negative pi over 2. Let's keep going. Way over here, that's negative pi. Let's keep going. There's negative 3 pi over 2. Let's keep going. A full circle is negative 2 pi. When you rotate a full circle around and you end up back where you started, that's a negative 2 pi angle. So right there, I'm going to label negative 2 pi. This concludes the lesson video introducing trigonometry, but more particularly introducing 2 different ways to measure angles, using degrees or using radians. And the angles that we're going to draw in pre-calculus class will always be drawn on an XY plane, instead of like in geometry where you simply drew angles on just plain white paper.